Good afternoon, chairperson, ladies and gentlemen. Let me introduce myself. I am Capt Ye Aung Naing, pathologist of Principal Disease Research Division from Defense Services Medical Research Center. For this symposium, I would like to present about the COVID-19 and immunity. The pathogenicity of the COVID-19 is complex and the virulence related to immune system. For example, the cytokine dysregulation, immune dysfunction, cytokine storm, heart immunity, and eventually vaccine. These all are depends on immunization for COVID. To discuss about this topic, we should not forget the structure of the SARS-CoV-2. It is spherical in shape. The virus membrane has four structural membrane components: M protein, S protein, amyloid E protein, nucleocapsid M protein. The most prominent features are the club-like projection called S protein. Is the main target for the neutralizing antibody and therefore of great interest in immune response and vaccine design. Immune response for COVID-19. As protective immunity does not exist in human and the coronavirus is capable of escaping innate immune response. It can easily proliferate in primarily infected tissue. Subsequent cell death result in the release of the viral particles and intracellular component to the extracellular space, which result in immune cell recruitment, the generation of the immune complex and associated damage. The initial primary immune response is a protective reciprocation by the human body to facilitate viral clearance. The outcome of infection depends chiefly on host-immune response. So COVID-19 can present a broad spectrum of illness ranging from mild to severe acute respiratory distress syndrome. This is the pathogenicity of COVID-19. The first part shows the SARS-CoV-2 and 3 and replication and release of new particles. The virus binds to the AC cell receptor by means of the S protein and spike and then enter the cell cytoplasm where it releases RNA genome and begins to replicate and release new particles. The second part is antigen presentation. The viral antigen is presented to the antigen presenting cell that present the antigen peptide by means of the major histocompatibility antigen presentation. It stimulates the both cellular and hormonal immunity. Immune effector cells release large amount of cytokines and chemokines. A cytokine storm that may rapidly provide acute respiratory distress syndrome, singles or multiple organ failure and eventually death. When the virus enters the cell, this antigen will be presented to antigen presenting cell and then recognized by the virus-specific cytotoxic T lymphocyte and initiate cellular and hormonal immunity. The microbial structure called pathogen-associated molecular pattern can be recognized by the pattern recognition receptor. However, SARS-CoV-2 can induce the production of double membrane vesicles that club pattern recognition receptor and then replicate in these vesicles, thereby avoiding the host detection of their detached RNA. It is a mechanism called immune evasion. Cytokine dysregulation in COVID-19. Upregulation of certain specific cytokines which are associated with more severe disease profile. Interleukin 2, interleukin 7, interleukin 10, granulocyte colony stimulating factor, interferon, gamma protein 10, monocyte chemotretin protein 1, macrophage inflammatory protein 1A, and humanocrin factor alpha level correlated with disease severity with higher level being found in ICU patient. Cytokine dysregulation. This disease severity correlated with humanocrin factor alpha, interleukin 6, and interleukin 10 level. Similar to infection with SARS, interleukin 6 proven to cause suppression of normal T cell division, probably explaining the initial presence of lymphopenia in COVID-19 patients. The role of cytokine dysregulation in causing severe COVID-19 disease is well established, and specific immunotherapy can be considered an important modality of treatment of this disease. Immune dysfunction. The immune-mediated issue is caused by the highly cytotoxic CD8 plus T cell. Moreover, they had a decreased immune cell count, including total T cell, helper T cell, cytotoxic T cell, natural killer cell, and B cell count in comparison with healthy people. Cytokine storm is an unregulated hyperinflammatory response that results from the systemic spread of the localized inflammatory response to the viral or bacterial infection. Level of acute response cytokine, humanocrin factor, and interleukin 1 beta, and chemotactic cytokine, interleukin 8, and monocyte chemotretin protein 1, raised early in hypercytokemia lead to increase in interleukin 6. This slide illustrates targeting cytokine storm via the genus kinase and single transmitter and inhibitor of transition pathway. During a cytokine storm, there is an increase in level of interleukin 6 and then found a complex with membrane-bound interleukin 6 receptor to add on glycoprotein 130 that regulate the level of monocyte chemotretin protein 1 interleukin 6 and granulocyte macrophage colony stimulating factor. Cytokine storm implicate the role of antibody against spike protein, which promote the agglomeration of pro-inflammatory monocytes and macrophage in the lungs. Also as against the general disposition of female to the development of autoimmune disease due to their enhanced immune response. Occurrence of cytokine storm in COVID-19 disease. For example, man die more over than the woman die for COVID-19 case. This slide shows the high risk for the cytokine storm. This is the intermediate risk for the cytokine storm they will COVID-19. Immunomodulator. Immunomodulators are the medication used to help regulate or normalize the immune system. The challenge as on date is to identify the specific treatment modality for the COVID-19. The drugs which have shown efficacy against COVID-19 in initial trials are following. They are chloroquine and hydroxychloroquine, interleukin 6 pathway inhibitor, JAK inhibitor, antiviral, convalescent plasma, interleukin 1 receptor antagonist, anti-tumor necrotic factor alpha agents, and corticosteroids. Chloroquine and hydroxychloroquine. It interferes with glycosylation of ACE2 receptor, impeding the viral entry into the target cell. Interleukin 6 pathway inhibitor. Interleukin 6 is one of the major cytokines in this uncontrolled inflammatory response. Tolizumab have the potential to reverse cytokine storm and reduce mobility. Antiviral, remdesivir, and their novel nucleotide analogs have shown efficacy SARS-CoV-2 as well as in SARS and MERS in vitro study. Convalescent plasma. Convalescent plasma or versus antibody therapy is based on the principle of administration antibody. In the case of COVID-19 caused by the SARS-CoV-2, the proposed mechanism of action by which convalescent plasma will offer protection is primarily for viral neutralization. Corticosteroid. They were tried initially in the current ongoing pandemic of COVID-19. Herd immunity in COVID-19. Herd immunity occurs when a large portion of community becomes immune to the disease through vaccinations or through the mass of the disease. It making the spread of disease from person to person unlikely. We set up the good example for herd immunity. The proportion of the population required for herd immunity depends on how infectious the virus is. This is measured by the basis reproduction number R0. How many people a single contagious person would infect in susceptible population. For SARS-CoV-2, R0 is between 2 and 3.2. For measles, R0 is 12 and herd immunity threshold need to 91.7. For influenza, R0 is 2 and its herd immunity threshold need to 50%. For SARS-CoV-2, between 50 and 67% of the population need to develop immunity through exposure or vaccination. To get to 60% immunity in the United States, about 198 million individuals would need to be infected, surface, and develop resistance to the coronavirus. For Myanmar, about 33 million individuals would need to be infected, survive, and develop resistance to the COVID-19. This slide shows the comparison between the no herd immunity and herd immunity achieved. Immunity through vaccination. Vaccines safely deliver an immunogen to the immune system and to train it to recognize the pathogen when it is encountered naturally. The nature of the immunogen and route of administration affect the type of the immune response induced, the protection and the duration of the protection. Immunogen may be attenuated pathogen, K-inhibitory pathogen, subunit, recombinant peptide, or nucleic acids. Now, many types of vaccines are produced by Russia, Sputnik, non-replicating viral vector vaccine, India, Covaxin, individual vaccine type, United States, Moderna, messenger RNA vaccine type, United Kingdom, AstraZeneca, adeno vaccine types. These are my reference. Thanks for you come to join and for your kind attention. May I invite for Major Tan Thai Wen for introducing his presentation.